All right, I just did a video where I graphed just this equation with this restriction. So if you feel like you need to watch that on its own before we do these two pieces, totally cool. Otherwise, maybe you are ready for this kind of video. So if I see two restrictions and two equations, so when I say two equations, I see an equation here, and I see another equation here, and then here are my restrictions. So this restriction goes with this, and this bottom one goes there. Okay, so basically I'm just gonna, it's called a piecewise function for a reason. I'm gonna do the equation in pieces. So I'm gonna start here, ooh, JK, I just fell. This equation is gonna start me off only because it's on the top. So I'm gonna graph it y equals 1/3 x plus 4. Begin at the back with the 4. The slope is up 1 to the right 3. So there's my second dot. I can do this a repeated amount of times if I wanted to. Down 1 to the left, 1, 2, 3, down 1, 1, 2, 3. Or I could have totally just done 2 dots and just connected those two. Totally up to you. More dots means more accuracy, but I'm just gonna go with it like that. So once I've graphed my line, now I need to look here for the boundaries. So what I see here is that there's only one boundary. So hopefully that makes sense. If not, then what I mean here is there are two boundaries, meaning x is trapped between two numbers. Here, x is only trapped by one number. There's only one restriction. So I'm going to, oops, too much. That's for the next video. So I'm going to take that -3 always on the x-axis because remember, this is like your timeline. So I go to where the time is -3, and then I make like a little dashed line because now my piecewise function is split into two pieces, chunk A and chunk B, and I have to figure out which chunk to keep and which chunk to erase. So at -3, and I read the description, it says x is less than -3. So I want my picture to only exist when the time is less than -3. So here's -3. Time that's less than that is over here on this side. So what that tells me is to keep section A and erase section B. Oops, too much. So notice I'm only finding one number on the x-axis because there's only one number here. So we graph the whole line. We find this value on the timeline. If this number is less than, we keep what's to the left. If this were greater than -3, we would have kept B. So right now, I'm going to follow the same kind of procedure. And I'm going to graph the second portion of that. So let's choose a different color. Maybe let's go with purple. Okay, so that equation is just 2. So this 2 and this 4 kind of look the same to me. So I'm going to follow the exact same procedure. I'm going to go to where the y-axis is 2. And since this equation has no x's, it means it has no slope. No slope means no tilt. No tilt means a straight line. So I'm just going to graph a straight line like that. And yes, I'm going into the green section there, and that's okay. You almost have to pretend like this line just isn't there temporarily. I mean, it is there, but just pretend like it's not for a second. And then now I'm going to go to the restrictions, and I see two restrictions, a dot at -3 and a dot, I'm sorry, not a dot, but like two values of -3 and 3 on the x-axis. So I'm going to find them on the timeline because, again, this is always essentially the time which your picture, your purple picture exists. So from -3 and 3, that's where my picture lives. My picture, that's what the x kind of stands for, lives in this section of the timeline. And that means everything else outside of the timeline gets to disappear. Now I know there's already like a lot going on. So that's what the picture should look like on its own. If somebody had asked me to just graph this, then I would have been able to go and draw a straight line, cut these chunks off. Oops, it's supposed to go all the way to 3. And that's what my pretty little picture would look like, with an open dot at -3 and a closed dot at 3. But no one really asked me to graph just that. They asked me to graph those two pieces, right? So let's just do this one more time real fast. Begin at the back with the top 4, up 1 to the right 3, graph my line, find the time, x equals -3. Remember, I'm just doing the top part here. Find the -3, chop the graph into 2 pieces. And again, there's only 2 pieces because there's only one number here. This says x is less than. Less than means keep things to the left and erase things on the right. So that's part 1. Make that a, is that my phone? Of course it is. That's not okay. Go away. Graph a closed dot at -4 because again, that's a inequality with an underline there. But again, we're going to mostly be seeing these kinds of things. So that's when you need to, that's a notation you need to know. And then the bottom one, I'm going to graph a line y equals 2. That's now the bottom part in purple. There are 2 restrictions, -3 and 3. So anything past that is going to get erased. Erase this, erase that, erase the boundary markers because we don't need them. Now I'm going to go in and put in my dots. Close dot here, open dot here. But again, the open dot is sitting on top of a green dot that was already filled in. So you can't make one dot look open on top of one dot that's closed. The dot that's closed is always going to look closed and it's going to fill in essentially the open dot. But either way, that's what the picture should look like. Hopefully that helps.